Hello and welcome to Strangle Your Legacy Code. My name's Amitai. Our goals for this session are to introduce what the Strangler is, develop in a real one, so this won't be very theoretical, and then because it's practical, we can notice what we learned along the way and talk about it a little bit. Before we start, I always like to highlight any conference or meetup that I speak at, whether it has a code of conduct or not. The reason about this is not that I know the best opinion about whether there should be a code of conduct or not, or how it should be written, nothing like that. Just that when I go to conferences and meetups, some of the people that I have learned the most from have told me that they will not attend an event if it at least doesn't have a code of conduct. And it's easy for me to move through the world. I'm a white looking guy. I'm cisgender. I'm a man. And I don't have this kind of a problem. I feel safe in many spaces, and I don't worry about that. But I want to make sure that I get all the ideas that I could possibly get when I go to a conference, and so I like to at least ask if they have a code of conduct. And it does relate to tech, because in test-driven development, one of the things we do, one of the ways it helps us, is as a cognitive aid. When we say what we intend to do, it helps us do it, and it helps us check ourselves. And a code of conduct is kind of like that. It says what we're going to do if something comes up and we want to know how we're going to intervene. So I don't see that there is one specifically for mini spa, and it's a little strange late in the day to bring this up at all because probably if something was going to happen, it would have happened by now. But there is a code of conduct for the larger SPA Software and Practice Conference, and so I've highlighted that here. Please feel free to check that out if you haven't seen it already. Thank you. Now, back to the content. What we're going to talk about today is the Strangler application pattern. It is a technique for coping with legacy code. Legacy code has a variety of definitions. Everyone's definition in our field owes a lot to Michael Feathers, who wrote the well-known book Working Effectively with Legacy Code. Feathers' definition is code without tests. And I have used many definitions, including that one. The one that is currently my favorite is code that is valuable that we are afraid to change, where tests are one way that we could get confidence or lack confidence if we don't have them. But what's important is the confidence. And if we could have that confidence some other way, that would be just as good. So I talk about the fear because that's primary for the experience of the people doing the development work. So that's legacy code. A strangler pattern is a way to deal with legacy code under certain conditions, and we'll talk about which conditions in just a moment. But first, the best explainer for any concept is usually Martin Fowler. Here's his explanation. One of the natural wonders of the Queensland, Australia coast are the huge strangler figs. They seed in the upper branches of a tree and gradually work their way down the tree until they root in the soil. Over many years, they grow into fantastic and beautiful shapes, meanwhile, strangling and killing the tree that was their host. That is vivid. So you can imagine something like an architecture diagram, except it's a tree and a vine, and eventually the vine it's more vine than tree by the end. So when do we use this? Because it's a big hammer. You might think I have legacy code, I can do the stuff in the Feathers book. I can get it under characterization tests being tests that at least tell us when the behavior of the code has changed, whether or not we know what right is. We at least want to have an explicit decision when we change something. Either we conservatively avoid the change or we accept the risk of the change. So we can get our code under characterization tests, that's fine. It takes some work, but then we can safely move under those tests and gradually modularize and gradually write things that are more like microtests, unit tests of small functions or methods. And then we can change our code. That's true. And for the lucky ones among you, when you're dealing with legacy code, you can get far enough, fast enough with legacy code that way. If you have a giant, historically large ball of mud, and you can try refactoring opportunistically as you develop new features, and you can conclude pretty quickly that in business time, we will never get anywhere worthwhile refactoring opportunistically, or even if we took like a 6-month project and all we did every day was little refactorings. even then we would still be behind. Then that might be a case for a Strangler application pattern. Because I'll tell you a little bit about how it's shaped in just a moment, but from a business case, compared to needing to refactor basically forever, it's cheaper. And then compared to what is now known as a classic mistake of a software company, compared to doing a complete rewrite of an application or a system, it's much lower risk. So there's a pretty strong business case when you're in the right situation that a Strangler is what you want. So before we get into a real Strangler, let me tell you a little bit about how this is going to work. What a Strangler is like is you could think of it as a giant proxy in between the application and users of the application. You could think of it as the world's biggest adapter pattern because it's an adapter for the entire external interface of the application. It's like an extreme version of some patterns you may have seen before. An easy example of what a Strangler is like in a domain that we all have probably worked with is a web application. So say you have a web application. It listens on port 80. For simplicity, we'll leave out SSL, TLS. And it routes the request itself to its own code and responds to those requests with its own code. And it's all the web server and the routes are and the code that handles the responses are all built in there. Now let's say it's big and hairy and we want to put a Strangler around it. In that context, what a Strangler looks like is a web proxy server. So Nginx or Apache or any one of those, you put that in front of your web application on the same port that users or clients are expecting to call. And then you move your web application carefully to a different port that the proxy knows to map things through to. And in your first deployment of this Strangler, of this proxy, your job is to make it invisible to users. You're not trying to change anything for users, not yet. First, you have to prove that you can put something in between users in the application and not change anything. And so that's actually one of the riskiest parts of deploying a new Strangler is step 0 is to put it in and make sure that nothing broke. If it did break something, then it's not transparent. Take it back out of production, figure out what you missed, try again later. If it is transparent, now you have a place to stand as you try to move the legacy code world that you're in. And so then once you have that, you could, for example, take part of the URL space and send it to a different backend, or a certain subset of user sessions and do something different with them. And then the idea is, this is how Strangler is shaped. You wind up with new code for new features in a new code base. And presumably, you do it with a new level of quality and manageability, so that this is code that is still valuable, but that you're not afraid to change. And that's the ultimate benefit. And so a couple of rationales for this might be, you might think that you want to slowly replace the entire original system, although it might take some years and you might lose the intention by then. Or you might just say, well, whatever the hotspots in the system are that we have to change, we'd like those to be more easy to change. And whatever we don't change very often is fine remaining in the legacy system. Either of those is a typical choice. So for our real Strangler, I'm going to remind you all about the company that we have worked for together for so long. Some of you have joined relatively recently, so maybe I can catch you up on the history. So we work for Acme Company, and in our department, we're responsible for the email service of Acme Company. And we made a major architectural decision in 1998. You can hear some of the age in my own voice. I was around for this decision. I still feel good about it. We all still feel pretty good about it, because the architecture of the open source email server we chose, which is called Qmail, is a great architecture. It fits together really nicely, and even though we often have to develop new features for our business or regulatory requirements, we find it generally easy to do because there are nice interfaces between components. Things fit well together. There are seams where we could change how things interact pretty easily. Now, there are some downsides, which is that this is code from 1998, first of all, period, and that even in 1998, it was a fairly idiosyncratic dialect of C. And so there are pros and cons, but sometimes we wonder if it could be cheaper to develop our next feature. And so this is where I used my 20% time because, as you know, we work for an enlightened company that gives us 20% time. On my 20% time, I was thinking, well, C can be error prone. Some of that is reduced by the custom idiosyncratic libraries that this application uses, but still, it might be slower and more dangerous than something like Python, for example. And, I looked at our backlog for the next quarter, and I thought maybe some of these features would be faster or safer to implement if we could do them in Python instead of in C. So on my 20% time, I developed a strangler around the SMTP service portion of our email server. And it's written in Python, and it wraps the SMTP service. And then I have some red tests for the features that we want to implement. Before we do that, let me show you. Let's go to the IDE. I will show you what kind of code we would be dealing with if we didn't do this. That's over here. So we're looking at qmail smtpd.c, and right around line 140 is where the function that I want to draw your attention to starts. You'll see that it, first of all, doesn't end on this screen. You'll see some idiosyncratic ways of dealing with strings. If you've done C, you will probably not have seen this function before. That's not your fault. It's specific to qmail. And we need to keep reading. And even if I know that what this function does is to parse something that might be an address and tell us whether it did parse or didn't parse, finally we're into different functions by line 200. So we made it all the way to 198. So even if I knew that that was the point of this function, I still would have a hard time convincing myself which cases were handled and that they were all handled correctly. I certainly would not want to come in here and change this code. So this is an example of the C code that we wish to avoid. And let me show you then the kind of thing we're going to do with our proxy. So this workshop actually, this is usually a workshop. I'm just going to do a live coded talk for you. It's usually an interactive workshop, and it arose from I actually had to solve this problem for an open source email server called qmail for a variety of reasons, where I did write an SMTP proxy, and I did wrap the original component to avoid changing it, but I did do it in C. But at least I can show you the kind of changes we're going to make. So on the left-hand side, that's the original unfettered qmail SMTPD. I've connected. You can see there's a standard greeting. If something with a 200 code looks kind of familiar from HTTP as being a successful kind of a code, you're right. HTTP's status codes were inspired by SMTP's status codes. SMTP is an old protocol, I think, from the 80s. And so one thing you can say, for example, is help. And this is an open source derivative of qmail that I've revived with some community involvement. Another thing you can say is hello, but without all the letters in it, because most SMTP verbs are 4 letters. Another thing you can say is extended hello, which is a way that a client and a server could negotiate extended capabilities that improve the effectiveness of the connection. And then you could say quit. And it's actually not case sensitive, so I'm going to be lazy and type lowercase pretty often here. Now on the right side, I'm going to have the same verbs. These are called verbs, help, hello, and quit. I'm going to send the same verbs, but you're going to see different responses from the server because I'm running it under a proxy, which is very much like the proxy we're going to work with in just a moment. And I won't bother explaining the abstruse reasons for this proxy, but you'll just notice that the output is different, even right from the beginning. And so I can still say something like help, but now it's a 2-line response. The eagle-eyed among you will notice there's a dash here and not there. We may come back to that later. I can still say hello. That will look about the same. I can still say extended hello. That will look about the same. And then I can quit. So we modified a couple things about this output. That's just an example. Now let's actually look at the Python code, same idea. the Strangler that I wrote on my 20% time that we're going to develop together in just a moment. So on the left side, there's an analogous component to QMail SMTPD called however you would pronounce this. And it says hello in this way, so I can say, again, you know what, let's skip the hello and the help and all that. It's pretty similar. What I can do is demonstrate that there's no such SMTP verb as word. And I'm going to say word up to the vanilla version of this component from 1998. And it's going to say, I do not know what you're talking about. Because in no version of the SMTP spec, even versions newer than 1998, has this been specified. So the server says, I don't know what that is. Sorry, quit. Now over here, we're going to use our Python strangler in front of our SMTP component. And you're going to notice it's a little more verbose in the output. This is going to help us understand the state changes as we make it. So to paint a picture, in SMTP, when you have a session, again, this is a little bit like HTTP. You have a request and then you have a response. In SMTP, you can have multiple of these in the course of a connection. You can even pipeline them and batch up a few and get a few back in the same order, all this kind of stuff. And so in order to see what our proxy, what our strangler is doing, we're going to show the state as the proxy received it and the state as the proxy is going to pass it on. So in this case, the server responded to being connected to, and we didn't change that response at all. And so we sent it verbatim to the client. And now I can say over here, word up, and now we can see the full 4 states. The request that the client sent was word up. The request that the proxy is going to send the server instead has a no op in front of it. I'll talk about that in just a moment. The server says, okay, and we pass that right back, and that's why we see it. And then quit. So this no op is a very important trick. We are going to rely on it for a couple parts of the features that we implement. No op is in the SMTP spec, unlike word up, and it is required. An SMTP server has to say 250 OK when it is asked for that, and it has to do nothing. And this is useful for making sure that, so let's say we didn't do that. Let's say we passed that through to the server. The server might get into a funny state. I happen to know in this case it doesn't, but in other cases it might, if we send it a command it doesn't recognize. And so in order to avoid that, no op doesn't set any kind of a state. It gets the server to say okay, it gets the client to respond, and there we go. Why do we have to send anything to the server at all in this case? We could just, in the proxy, we could catch that we said word up. We could reply all by ourselves, never talk to the server. My first implementation of my C version of this project did that. And then I ran into the fact that the server has a timeout. And if you don't tickle it by sending it some kind of request when the client sent it a request, then you will time out when the server shouldn't have. And that's why I just always make sure to send some kind of request through, and no op is really handy for that. So we're going to see these 4 states pretty often as we work on our code. Now then, let us ship our next feature. So here we are in our tests, and here's the first one. The business made an urgent and persuasive case that we need to be able to type bye and have the same effect as if we typed quit. You saw me type quit a few times, and that causes the session to end. And so they said we need to accept bye and treat it the exact same way. And we can do this because we have a strangler, we have a proxy, without changing the SMTP services code. So we're going to. First things first, let's make this test run. And we can expect that it does not pass. And indeed it does not. So it's a little bit abstruse to read, but we were asserting that the request we send to the server instead, again, the proxy receives a request from the client, may modify it before sending it to the server. This is the one that it's going to send instead to the server. It's saying, when we received bye please, that we instead were going to send quit please. But we didn't. We sent bye please verbatim. So what we have to change here has to do with a request. And one of the few virtues of this Strangler code base is that that happens in requests, like you might expect. And there's a clue here that we can find in this code, thanks to our word up example, which is there's a little Python dictionary here. This is an associative array or a hash or a key value kind of a thing, depending on your language. We can just add to it and do something slightly different in order to make buy be treated like quit. So when we receive the verb buy, an SMTP has this notion of verbs and then arguments, and the verb is everything before the first space, and the argument is everything else. So when we receive the buy verb, let's invent a new little helper function where we modify buy. And it might be a little bit like this other one, but not exactly. So I'm going to duplicate this, call it modify by, and this one's a little simpler. We saw with the no-op example that it did somewhat well at preserving the original request and just appending it with a no-op at the beginning. That's this elaborate construction. We aren't going to need that. We just want to replace the by verb with the quit verb. So I'm not going to do that at all. I'm just going to return the argument we were passed. And I'm going to say the verb should be quit instead of buy. And let's see if that passes the test. Indeed it does. Okay, so we have shipped one new feature. That was pretty quick. That might have been quick in the original C code. I'll give you that. Let's do something more involved. So for that one, we modified the request. We didn't have to do anything to modify the response. We just wanted to make sure that the request looked like a quit by the time the server saw it, and then we get the right response. This one will be a little bit different. This one says that we should invent a new verb again, so that we need to do something with the request. The new verb should be called conf, and we want to have that return the URL of the conference that we're currently at. Here it is. It's a little bit long. So this is a little more involved. We have to mess around with the request that we get in order to put a no-op in front of it. And then we have to mess around with the response that we get from the server, which would usually be 250 OK with a no-op, and make sure that it's 250 this. So in this case, the proxy is going to modify both the request and the response. Let's see if it does this already. My strong conjecture is that it does not. Indeed. And so the test stops running at the first failed assertion, which is this one on line 34. So let's look into that. Yeah, all that happened is we sent a conf right through, and that is not what we were expecting. So let's head back to requests, because we're going to modify this request again. And I think this one is going to be a little bit like word, because it's going to put a no-op in front. So I'm just going to say when we see a conf verb, we should do the exact same modification. And I think that that will get us to the next assertion, and it does. So we were hoping to see 250, meaning some kind of success, and the mini spa conference URL. But what we did see was the incredibly fake server response that I cooked in the test. And so that means we didn't replace whatever the actual server would really have said. Let me show you, these are little Unity kind of tests, but let me show you in integration if we actually ran the Strangler, how this would look, just to give you an idea of what's going on. Yeah, so again, we have these multiple states. One thing we already did is that we made buy a synonym for quit. So you can see buy was replaced with quit, and then the server does what it does for quit. Another thing we could do would be to say conf. And you can see that part of this is the way we want it, just like you might think from the test. It stuck a no-op in front of it, and so this is fine. And then because we said no-op, the server said 250, and we haven't fixed that part yet to say what the URL is. So that's next. I can say quit or buy. I'll say buy. It's shorter. Cool. So the next thing we have to do is modify the response. And again, this is one of the few virtues of this code base. I'm just going to be nice and lazy and take this entire byte string and go over to responses, which is the place we need to change. Now this one is going to be a little more involved. If you feel like this code is not self-explanatory already, you are right. It is not your fault. This code is a little bit messy, and that will make for a discussion point later. But I happen to know it somewhat well, and so we can get by in the meantime. Here we have a modify message on responses, just like we had one on requests. This one is a little more involved because when we are changing a response, we need to know what it is a response to. Therefore, we need some state, at least as the code is currently set. Fortunately, I made this work where this gets called, and whenever a verb and an argument are sent to the server, or sent to the proxy, which we will then send to the server, we have a chance to note which verb and which argument those were and do something with them. So let's work from there. What I want to say is, if the verb was conf, set a Boolean, and then when it comes time to change the response from the server, we can look at that Boolean in modify message. So let's go do that. Again, step one is if, let's see if I remember how to do it in Python. If verb, I think we can say upper, just to remove that variability, is, I should do it as a byte string because everything's a byte string, is conf. Then I'm going to invent a Boolean here. Verb was conf. And I'm going to say it's true. And I'm going to come back and check that in a moment. Is this going to do what I want? Yeah, I need to define this on the class so that the object will have this Boolean. Is this going to do what I want? Nope. Okay, so I'm just going to say copy it, paste it here, initialize it to false. And now self verb was conf is true, and now when I come to modify the response, I can inspect that. If self verb was conf, then in this case I want to replace the message. So message equals, whoops, I lost my copy buffer. Here it is. Message is that. Now then, let's see how this goes. That is manual. I want to run the tests. So we'll do here. Yeah, that passed. Let's convince ourselves in interactive usage that this is decent. So we'll run IO Strangler. This is like a manual end-to-end test. So as usual, I can say hello, and I can say conf. And you can see, so this time the proxy puts a no op before it sends it to the server, and the server says okay, and we replace it with this. This is great. I'm going to say bye. Whoa, whoa, what happened here? This URL is still showing up, and we rewrote the usual quit response to be like this. Well, the eagle-eyed among you will already know the answer to this. It is because of my complicated state management. I should probably say self verb was conf is false before I go any further. And that way, next time I check, even if it's a different verb, I won't say that I should change the message. I bet that works better. I bet that passes the tests equally well, because I'm definitely outcoding my tests right now. These are more like BDD tests than TDD tests. Also, they're not that easy to read. There's a lot we can talk about with this. So the test passed just as well, which is mildly concerning if you're worried about how good the tests are, which we could be. And then if we run manually, let's go through the same song and dance. Hello, conf, still good there, and then bye. Okay, that's back to normal. So at least as far as we can tell manually, the state management is good again. Okay, so we've shipped two of our features. Let's look at the third one. This one says that in the extended hello response, this is how, remember, clients and servers can negotiate additional protocol capabilities. Um, in the extended hello response, the business explained that for regulatory reasons, we need to advertise the latest version of the GDPR legislation that we comply with. And that way, somebody sending email to us could factor that into a decision about whether they want to send a particular message to us or not. And so what we want to do for this one is a little bit more involved. This time we don't have to change the request at all because this is a real SMTP verb. The SMTP server will already have a response when we make that request. What we want to do is not replace the response, but append to it. So you can see, for example, lines 43 through 45. Here is an example of a response that the server might return. And then what we want to change it to in our proxy is just as it was before, plus one more line. Now, the eagle-eyed among you may say, because we had this come up earlier too, in the first example, we have a dash, and then a space in the fourth position of this multi-line response. And in our new one, we have a dash. We changed this one to a dash and then a space. And that might be enough information for you to guess that when text-based protocols were being designed in the 80s, bytes were expensive. And the way that you would determine if the SMTP response is complete or not is whether the fourth position is a space or a dash. And so that's why, actually, we glossed over this, that's why there is this reformat multi-line response. Because we may have modified a response in a way that doesn't comply with the dashes and the spaces, and that's fine. Every modification shouldn't have to keep track of that. We should just reformat it once before we finally send it back. And that is here. Suffice it to say that that's not the most readable code either. But it does work. So our task for this feature, which let's just prove has not been implemented yet, is whatever the server responds to this verb, this real already existing verb, we want to append this line to it. So I'm going to get out ahead of us and hope that my paste buffer survives this time. I want to take that and add it to a response. This will again be in responses. We don't have to do anything in requests this time. In this case, if verb.upper is extended hello, and self verb was extended hello should be true. And I'm going to copy and paste that in just a moment because I learned my lesson from last time. If self verb was hello, I also learned this lesson from last time. Unset it before I move on. And then in this case, append to the message. So on line 58, we replaced it. And on this one, we append to it. And then there's one more thing I have to do, which is make sure that this exists in the first place. And let's take care of that. So I bet that makes the test pass. And it does. And let's see how it goes for interactive use. So again, I can say hello, I can say conf, and I can say hello again, and it gives a normal hello response because it didn't keep the state of the conf response this time. And then I can say extended hello, and you can see I didn't change the request because it's a totally valid request. I did change the response. So the server wanted to tell us this, and what we're going to send to the client instead is this. So that looks pretty good. Assuming that we can type conf again, and that looks normal, and we can type by, and that looks normal. Okay, not shabby. Finally, one last feature, and then we can get into what we've learned from this. So this last feature says, if Amit tries to send me email, well, tries to send anybody email, we should reject it. Sorry, Amit. I'm sure we've all enjoyed the conference, and I hope you don't mind that I'm poking fun at you. The first time I did this, the email that I was rejecting was from my co-facilitator. So hopefully you don't mind that I'm poking fun at you. So in this case, this is actually pretty frivolous because there's a feature in the mail service that merely needs to be configured. It doesn't require code, it just requires an entry in a configuration file. The mail server already has this feature that you can specify addresses, envelope addresses they're called, which are not the same as the from address in your headers. They usually are, but they don't have to be. But so the envelope sender is something that we can just put in a configuration file for the server and it would reject it, and this is exactly what it would say. And so we're just looking to reproduce a tiny subset of that feature without having to write a configuration file. It might be easier to test, who knows. So in this case, we're going to not modify the request. Oh no, we are, right. We're going to stick a no op in front of it. And then we're going to respond this instead of OK. So again, I conjecture that neither of these assertions will pass yet. Right, so we didn't stick a no op in front of a mail from. Let's get on that. This one is back to requests. And so I suppose we could say, so we don't have to be very precise about this. Before I go any further, actually, this is one of approximately 13 zillion combinations. That's not exactly the right number, of whether the from part of the argument is present, whether there's a colon, whether there are brackets around the address, whether the address has just a local part or a domain part. And so there's a zillion combinations, and the real mail server has real code that is really hard to believe that it handles everything, and there aren't test cases, but it does handle all those cases. We're not going to worry about all that. We're just going to say if the verb was mail, and maybe if the argument was exactly this. That's good enough to make the test pass, and then we can stop and talk about this architecture. So we're going to do that. So if the verb is mail, I'm going to stick a no op in front of it. That ought to move the assertion forward. Yeah, and so now we're failing on the second one. And we should have gotten 553, but we got 250, okay. So for this one, we have to modify the response, and we're just going to do a good half job of that. I'm going to say again, copying this terrible pattern for effect, you understand, not because this is my favorite style. I know we don't know each other yet, and I don't want you to have a bad feeling about me. This isn't the code that I think is great. This is code that I think is making for an interesting discussion. So if the verb is that, then we can say, in fact, let's say if the verb was that, and the argument, I'm going to be really literal, go back to the tests and copy this. I should have done it with quotes. I think that's right. And if the argument is that, is this not how you do it? Is it and? I don't write in Python very often. Then let's say mail was from Amit is true. And then if self mail was from Amit, unset that state for next time. And message, we're gonna go get that from right here. Should be this one. Let's see if I remember my IntelliJ keystrokes. Nice. Message is that one now. And then of course I need to make this be a real thing on the class. It's getting a little repetitive and starting to feel a little funny. All these booleans and action at a distance and all that stuff. But maybe this would work. So let's see. Test pass? Not quite. Oh, what did I miss? Maybe this already got chomped. Is that the one? Yeah, okay. Programming by wishful thinking. So So we have all these tests passing, which you could take to mean, in a very loose sense, that all these features are shipped. Um, the code is pretty weird, and if you didn't come here knowing this code that I wrote for the Strangler, you would probably have had a harder time finding your way around and figuring out where to put things and understanding the state and the action at a distance. If you didn't have an intimate understanding of SMTP, which fortunately we all do because we work at this company in the mail server department, then there's a lot to read in this proxy about how we can trust that it is parsing SMTP correctly and not breaking anything that ought to work. But we didn't look at any of that. I just did this on my 20% time. So let's bounce back and think about the context where all this happened and how it went. First, some use cases. When would a pattern like this come in handy? We talked about as an alternative to huge refactoring forever, or as an alternative to keep this one thing off to the side and write an entire parallel rewrite, no matter how many years that takes, no matter whether we have to add a feature in two places for what we thought was going to be a short amount of time until the new one is done, but turns out always to be a long amount of time, if the business is still in business by then because we're wasting a lot of development effort, so on and so forth. So it's an alternative to big rewrite or big refactor. When would you feel positively drawn toward it? One case where this could be handy is if you have a monolith and you want to move incrementally toward microservices. And so you could easily imagine, for example, like we wrote all this Python code directly in the Strangler, which was Python. But you can easily imagine that we could farm out the responses for particular verbs to different microservices running somewhere else, written in a different language, so on and so forth. And so, a preponderance of the SMTP functionality would continue to be C from the original code, but in particularly interesting parts or algorithmically challenging parts or God knows what, we could have microservices that answered instead, and we could choose a different language as we wish to, if we wanted to. Another use case is if you have an old system that doesn't do any kind of interesting logging, you might not even know which parts of the system are used. And so it might be relatively easy compared to instrumenting the old system to put a strangler in front of it that does the instrumentation and shows you where the requests go and what actually, are there parts of the system that are dead that we could just get rid of? And you could find that out pretty quickly. And there are other things you could see from that as well. You could do this if you had the intention to eventually turn the original system off, although it could take some years. Or you could do this without that intention at the outset, just like I said earlier, to make sure that the parts of the code base that change a lot are relatively easy to work with. Techniques are important here too. So we talked at the beginning about that first deployment of a strangler. That's maybe the riskiest deployment because it's a big jump from an application that is directly facing outward to an application that is fronted by some kind of a proxy or a strangler. Something that's very important that we didn't touch on at all here is if you have some kind of a data persistence layer. In the case of a mail server, this is relatively simple. What happens at the end of this SMTP conversation, if it was successful, a message goes into the queue, and then some other component of the mail system processes the queue. But typically, you would pick a strangler for a large, complicated application with a data layer, a data persistence layer. And this can be a challenging part of a strangler implementation is neither of these options is great. One of them is we find a way to reuse the existing data layer so we can continue to have one copy of data, one way to access it, one set of constraints enforced in one set of places. But then we're dealing with legacy code for our new code, and maybe that gets in our way. Or we say, let's go route around that and pick some other way to get at the data. Maybe we have, a downstream copy that has new information in it, and that way we avoid breaking, the legacy layer, querying the legacy data, but the new layer has new information in it, for example. But then you have to manage two code paths, maybe two data sources, and making sure they don't get out of sync. And another technique here is when you're taking a feature from the legacy system and maybe re-implementing just the feature or moving the feature to a new code base, then you want to, if you're not sure, one way to migrate safely is for a request to be routed to two places. And maybe if you're really conservative, you actually send the response from the old place to the client, but you also call the new place, and then you compare the results from both in a place that can be inspected or maybe automatically inspected. And when you're convinced after enough different kinds of requests have been handled equally well, then you could flip the switch. And so that's another technique, is to have feature flags here where we can control where a request goes. Another important thing to do when you have a strangler is when you get code that is now unused, get rid of it. When you have data that is no longer accessed, get rid of it. Part of the carrying cost, which for legacy code can be very large, is code that, just maintenance cost of code. And so as soon as you can convince yourself that some of this stuff is out of the picture, get it out of the picture. Now, this may be what's top on your mind after watching me work with this code. There are risks involved here. This is not a panacea, and this is not a golden ticket out of legacy code world. Again, we talked about that first deployment of a strangler. That can be risky. You have to really make sure that you cover all your bases or that you can roll back easily in case you didn't. You may have data in two places or access two ways. You will wind up, at least between the beginning of the strangler and some theoretical end of the strangler, with an architecture that has even more parts. That's guaranteed. And so that may cause some trouble. You may find that ideas from the old code that are outdated, language, domain concepts, metaphors, wind up getting used in the new code, and some of that may be beneficial, some of it may not. A major concern, especially if you saw what I was working on just now, is that who's to say that this strangler or the code that it points to isn't also going to become legacy code? Because what we were working on just now is starting to get a little hairy, and it's only been a few of my 20% times putting that together. So if we were going to make a calculated decision to invest in that or not, I think we would want to start with getting that under test, or maybe treating it as a spike and test driving a replacement for it. And then another risk, because a strangler is a long game, is that whatever goals were chosen at the outset of the decision, why we're doing a strangler and where we hope to get with it, may be forgotten or may be displaced, which is not the end of the world. Maybe the new information comes to light that suggests they should be displaced, but it may just be that they're forgotten. So before I stop for some questions and ask for your feedback, here are a few resources. There will be a link in these slides to the code base that we have here. I'm going to git push it in just a moment. And by the time you see this, you can be able to pull it on our branch. Here's Martin Fowler's vivid description of the Strangler application pattern. If you like legacy code, whether dealing with it with a strangler or whether you're playing with the Mikado method like Philippe presented, Legacy Code Rocks is an online community of people who mainly identify as menders rather than makers. And so there's a podcast and there's a Slack that you can join to find some like-minded people who really enjoy legacy code. I enjoy legacy code because I know that it's valuable and I know that there's feedback. If I make a mistake, I will hear about it. And then usually when I do this, it's not me live coding. It's some volunteers, either a team or people at a conference who don't know each other until now, working as a team with some guidance from me. And I can see what they stumble over in this code. And that's part of what the discussion turns into. And so we do that as a mob. Here is a guidebook, a free guidebook for how to start doing mobbing in your own teams, and a role-playing game that really encourages productive team behaviors in that context. Couple more things. I have a podcast. It really is 180 seconds or less. It's about Agile, and it has helped many teams and managers and coworkers have conversations. I picked a couple episodes, one about caring and one about mob programming, because they're relevant to this in the form of a workshop. There are many other episodes. It's on iTunes. It's on anything with an RSS feed, Stitcher. It's in Spotify. So check that out. If you don't like it, it's over in a few minutes. There's also a book, because these are basically essays, spoken word essays. And the cheapest possible price I can give you is with this coupon code. So please feel free to help yourself to this book at the low, low price. And that was Strangle Your Legacy Code. My name is Amitai. I'd like to open it up for questions.